Introduction to a permeability in a soil. So, understanding a soil permeability is vital in a geotechnical engineering. It controls water movement through the soil and affects stability, drainage, and construction safety. Permeability is one of the most important properties of a soil in a geotechnical engineering. It refers to the ability of a soil to allow water to flow through its pores. Its property is crucial when dealt with groundwater flow seepage through the earth structure like dams and embankment and in foundation engineering. So, a good understanding of a soil permeability helps to engineer design safe and efficient drainage system, retained walls, and other soil related structures. Then, what is the permeability and why does it matters? Definition for the permeability is permeability measures how easily water flow through soil pores. It defines the pores, the water flows through pores which is available in a soil. Importance, it is important foundation to foundation design, slope stability and groundwater flow. For any construction, before doing the construction we have to know about the property of the soil. On that soil, where after next 1 or 2 years we have to work or we have to construct a building on that soil. The behavior of that soil is very important, or it has a very brittle role in the construction purpose. Practical effect, the high permeability may cause a rapid drainage, low permeability can lead to waterlogging. So also the coefficient of permeability, the factor is K, is a key parameter that represents the easy to with which water can move through soil pores. It's until is the water, the value of a K is a very high in a coarse soil like a gravel and a very low in a fine soil like a clay. For example, in gravels K and be around 10 raised to minus 2. Then next, Darcy law, the foundation of a permeability analysis. The Darcy's law, the concept of a permeability is best explained using Darcy's law. Henry Darcy in 1856 conducted experiments on a water flow through sand filters and proposed this law. Concept, water flow rate is proportional to hydraulic gradient and the soil permeability, and the Darcy law indicate the formula which is Q is equal to K into I into A, where K is the permeability, I is the hydraulic gradient, and A is a flow of area. Here K is called of coefficient of permeability. This value depends on the soil type and determines how fast water can flow through it. Coefficient of permeability K. The coefficient of permeability is a key parameter that represents the ease with which water can move through soil pores. Its unit is meter per second or centimeter per second. The value of K is very high in a coarse soil like a gravel, very low in a fine soil like a clay. For example, in a gravels, K can be around 10 raised to minus 2 meter per second, while in a clay, it can be as low as 10 raised to minus 9. There are some factors might be affect on a soil permeability. First is soil texture. Coarse soil like a sand have a higher permeability than clays. So we can say the clays have lower permeability than soil like sand. Soil structure, we aggregated soil, well aggregated soil allows easier water flow through connected pores because the well aggregated soil having much amount of air gaps in between them, so water can be easily goes through it. Moisture content, a saturated soil conduct water better, dry soil may resist flow. Heavy compacted soil reduce pore space and permeability. There are some might be another which is non shown on this PPT. I would like to just share that a grain size large particles have more space between them, allowing water to pass easily. Void ratio, soil with more void allow more water flow. Then soil structure, layered, this is covered in that. Degree of saturation means moisture content. Dry soil have a less permeability than a saturated soil. Water properties, temperature and viscosity of water also affect flow rate of the uh, water. So here we can say, like to share that the types of soil permeability depending on the soil type, permeability can be classified as high permeability gravel, coarse sand, medium permeability fine sand, sand, silt or sandy silt, low permeability clay, silt clay. This classification helps in choosing the right soil for different engineering applications. Also, the laboratory methods for determining permeability, constant head test. In a constant head test, measures flow through coarse soil under the steady water levels. Coarse grained soil like sand and gravel, water is kept at the constant height and the flow is measured. Falling head test, another test for a laboratory test for a soil permeability, used for a fine grained soil, measured a rate of flow level drop. Used for fine grained soil like a silt and clay, the drop in water level is recorded over a time. Textile permeability, triaxial permeability test, sorry, evaluate permeability under controlled stress and saturation. Field methods are also included that, but I have not mentioned in that, so I can quickly revise that. In a real world conditions, field tests are more accurate. Common method included is a pumping test. Water is pumped from a well and a flow rate is observed. Also, percolation percolation test using mainly for drainage and septic design. Determining permeability, infiltration test measure water absorption rate at a soil surface in a site. Also, pumping test, we have already discussed about pumping test assessing permeability from groundwater drawdown response. Also, a sludge test analysis water level recovery in a well to estimate permeability. Also, the application of a permeability in a geotechnical design, a drainage design, ensure excess water in a safety, remove or protect structure. Seepage analysis predicts water movement through embankment and dams. Soil improvement selects methods like drainage or compaction to adjust the permeability. Permeability in a stratified soil, a layer variability, different layer have a contrasting permeability affecting flow path. uh, Preferential flow water tends to move faster through coarse layers, bypassing fine soils. Seepage control, identifying low permeability and a conclusion, key consideration for a practice. Understand the soil variability. Permeability differs greatly by soil type and structures. Use appropriate test, select or field methods suitable for site condition. Apply data in design in compare permeability insight to ensure stability and